So lesson 3.6 is just an extension of the application of Newton's laws of motion. In this particular type of questions, the uh, the mass or the masses are accelerating. So therefore, mainly you'll be using the second Newton's law. Okay. So let's start with example number 1. So calculate the acceleration of the frictionless pulley system below. So we're given that our mass of the first object, so this one here, the bigger one, has a mass of 5 kilograms. The other one has a mass of 3 kilograms. Okay. So um, maybe perhaps in the book you'll be given a different way of solving it, but I'll be presenting here a solution that will be, I find it, well, in a sense, will uh, give you a better understanding on how to apply both the first Newton's law or the second Newton's law. Okay, so in my solution, what I'm gonna do is I will try to draw the free body diagram of each. Okay, so FBD of capital M1 and M2. So I'll be examining the forces individually for my M1 and M2. So for M1, I'm going to start with M1. If this is my M1, what are the forces acting on my M1? Well, it should be that this M1 is attached to a string. So there must be tension force. Okay, so I'm going to call that one as FT. And again, for any object on Earth, well, this is a particular object should be taken into that this is on Earth. So you have Fg or weight of the object. But remember that I have two masses here, M1 and M2, and their values are different. So just to assign a different variable for the weight of my first object, I'm gonna call that one also as the weight of the first object, or Fg1. And we know that the magnitude of the weight is just equivalent to the mass of that object, M1, so in this case, capital M1, multiplied by the acceleration due to gravity. Again, it's not gravity, but acceleration due to gravity. So if I'm gonna get the magnitude of the weight of the first object, that is equivalent to 5 times 9.8. So in this case, I will not be rounding off yet because the main question is anyway calculating the acceleration. So whatever is the value that will give me there, I'm gonna write it down. So that's 49 newtons, okay? So now, it's also relatively important to identify the direction of our acceleration here, okay? So although it will just come out naturally in your computation later on, but if you're gonna compare the two, M1 is bigger compared to M2. But the tension here, the Ft on your M1 is should be coming from the pull of your M2. So if you're gonna see here, generally the motion or the acceleration of this whole system would be, by just comparing, it would be counterclockwise, right? So that would be the motion. That means that this will move down and this goes up. Okay. So based on your M1, the acceleration of M1 would be going downward. So looking at this free body diagram here, I'm gonna set my acceleration as downward to be the positive value. So downward motion, I'm gonna set that one again down, or that is counterclockwise. That means that anything that is in that direction, I'm gonna set that one as positive. Okay, so I'm gonna choose that coordinate system for when taking note of my M1. So now I'm gonna check my M2. What is the free body diagram of my M2? So my M2, so I'm gonna check what are the forces acting on my M2. Well, in this particular case, for this type of questions, we uh, try to take note that we will disregard the mass of the rope, as well as the pulley is frictionless. Okay, so that means that the weight of the rope and the friction within your pulley is being disregarded. So in this particular case, the tension felt by my M1 is actually the same tension as felt my M2 here. So it must be that this FT has the same magnitude as the FT in my M1. Okay. Again, that is true in this particular case because we try to neglect the effects of friction, okay, as well as the weight of the rope. So that somehow simplifies our problem. But again, you don't have to worry about that one because all of our problems would be something like this. We try to assume that the friction is negligible as well as the mass of your rope, or it could be string or what. And again, you have FG here, but since it has a different mass, I'm gonna call this one as FG2. And this is just equivalent to the mass, the value of the mass of the second object multiplied by, okay, multiplied by 9.8 or G. So if I'm gonna solve for that, that would be 3 times 9.8. So FG2 is equal to, again, I'm just gonna get the magnitude of this 29.4 newtons. Okay. So with this, I know that it will be moving counterclockwise here. So that means that in this M2, I'm gonna set the acceleration here is upward. So I'm gonna set my upward direction here as positive because that is the direction of the acceleration of my M2. Remember that as a system, this object, M1 will move down, M2 will move up, okay? So the direction of the acceleration of my M1 is going down, and the acceleration of my M2 is in upward direction, okay? So therefore, I'm gonna set that one as my positive direction. And now I've written my free body diagram. The next thing is I'm gonna check the forces acting, the net force acting on each object. So you try to set your equation. What would be the forces or the net force acting on my first object? And remember that this is accelerating. So therefore, the net force, or the sum of all the forces acting on my first object, is just equivalent to m1 times A. And if you can see here, again, uh, the magnitude of A for both is just the same thing. They will move with the same acceleration. So therefore, I'll just use A. I'm not using A1 and A2. If you can see here, I'm just using same value for A's. Because anyway, the acceleration for both would be the same. They will be accelerating at the same value. Although one is moving up, the other one is going down. Okay, so now I'm gonna get the sum. What are the forces acting on my first object? Well, if you can see, that's Ft and Fg1. Okay, so I set my positive direction as downward. So that means that in the opposite direction of that would be a negative value. So what I'm gonna do, if I'm gonna expand that one, I have Fg1, and that is positive. Then plus, again, Ft there represents the magnitude of my tension force. So that would be the negative of Ft, because I'm setting that one as the downward direction is positive. So therefore, the direction of your Ft here is upward. So it's negative value is equal to M1 times A. So now, if we're gonna substitute the things that we know, well, we know what is our Fg1. So therefore, we can substitute that one here. That's 49. But plus the negative of Ft. Okay? M1 is also given. It's given by 5. So I can substitute that one. So this is 5A. Okay? So Fg1, I know the value, that's 49. So if you can see here, I have one equation, but with two unknowns. Okay? So therefore, this is not enough. This is not enough for me to answer either in solving for A. Okay? So therefore, I need another equation because I have two unknowns. Again, in algebra, the number of unknowns should be equivalent to the number of equations. So I'm just going to take note that this is my equation number 1. Okay? However, I have another object here, my M2. So I'm going to check. So what are the forces acting on my second object? Well, I know that this is accelerating. So therefore, the net force acting on M2 is equivalent to its mass, M2, and the value of its acceleration. And again, acceleration is just represented by A. And now I need to expand that one out. What are the forces? Again, F net is equal to 2 only means that I'm trying to get what are the forces or the sum of the forces acting on my second mass or my second object here. Again, there are two forces here, my Ft and Fg. And remember, in this particular case, again, this is another object. So therefore, I can change my coordinate for this, for my reference. So again, it's much easier if you're going to set the direction of your acceleration as the positive value. So that means that this time, for my second object, upward direction is positive. So therefore, if I'm going to expand my forces acting on my second object, it would be Ft plus the negative of Fg2. And this would be equivalent to M2 times A. So now, I'm just going to substitute the things that I know. So again, the magnitude of the weight of my second object is given by that. So I'm just gonna substitute that one. So FG2, so gonna substitute the value of that. So FP minus 29.4 is equal to, I've given the second mass, the mass of the second object, it's 3. So I'm just gonna substitute 3 kilograms and then times the A. Again, 3 there is just the magnitude of my mass. So now, if you can see, in this equation, I created another equation, but exactly the same variables, if you can see. I am solving for FT, or my variable here, or my variables here in my second equation. I'm going to call this one as my second equation. FT and A. Okay? So I have FT and A. So you have two equations, two unknowns. So therefore, these two equations, I can work with them and solve for, yeah, whatever is the what is being asked. So there are several ways of doing this one. If you can remember your systems of, well, these are just linear equations because we cannot see a power of 2, right? So everything is just the power of 1. So therefore, this is just a system of linear equation. So how would you solve systems of linear equation? If someone, can you still remember that? How would you solve for systems of linear equations? Anyone? No idea? Okay, I think the most common, there are two methods here. It's either elimination method or the substitution method, okay? So again, there are two ways of answering solving systems of linear equation. So first method is elimination method. The idea here is you want to eliminate at least one variable, okay? So if you can see these two equation, I can actually eliminate ft if I gonna add equation 1 and equation 2. So if you can see here from equation 1 is given as 49 minus ft is equal to 5a. So if I gonna add that one with my second equation, again, this is my first equation. If I gonna add that one with my second equation, I just have to rearrange this one. Remember, this is plus ft, and this is negative 29.4 is equal to 3a. So again, if I gonna add the two equations, it's called elimination because generally the method is that at least eliminating one variable, and you can do that by adding or subtracting the two equations. In this particular case, we're adding the two equations. So if you can see, if I gonna add the two equations, I'm eliminating my ft. Okay, so this will give me what? If I'm gonna add that one, that would give me 19.6 is equal to 8a. So if you can see, by adding the two equations, I'm eliminating my FT. And remember, I'm solving for A, well, which is just dividing both sides by 8. So A is equal to, if you're going to divide that 2, the value is around 2.45, okay? 2.45 or 2.5 into significant figures, 2.5 meters per second squared. And indeed, since this is a positive value, that means that we correctly identify the direction of your acceleration. So therefore, we say counterclockwise. So therefore, your answer is 2.5 meters per second. And instead of using up or down in this particular case, we just use the term counterclockwise or clockwise, okay? So in this particular case, if you can see, well, the movement of the pulley would be in the counterclockwise direction. So therefore, we use the word counterclockwise for its direction. Okay, so this is by elimination method, although the most common in this particular case is using substitution. Yeah, I just gonna show that one here for the benefit of everyone so that you can remember your systems of linear equation. You can also use substitution method. Substitution method. Okay. So the idea is that you work with the two equations. So I'm just gonna write the two equations here. You have 49 minus FT, and that gives you 5A. So this is equation number 1. And then equation number 2 is FT minus 29.4 is equal to 3A. So that's my second equation. So in substitution method, you just have to express one unknown in terms of the other. So let's say, for example, I want to solve for A, right? So therefore, from equation number 2, I'm gonna express my FT in terms of A. So is it not that FT could be written as equal to 3A, and then if I'm gonna transpose my negative 29.4, that is just plus 29.4, right? So FT is just equivalent to 3A plus 29.4. So if I'm gonna call this one 2.1, okay? So equation 2.1, because that is coming from equation number 2. So this is coming from equation number 2, okay? So what I'm gonna do next is I'm gonna substitute. You're gonna substitute 2.1 to 1. By the way, don't substitute 2.1 to 2, because that is where your 2.1 came from. That's coming from your equation 2. So therefore, you're gonna substitute that to the other equation. Okay? So that means that FT would be replaced with FT should be replaced with 3A plus 29. So therefore, if I gonna write this one, that's 49 minus, and I gonna substitute that one with 3A plus 29.4. Okay. is equal to 3a. No, 5a, sorry. It should be 5a again. That is coming from your equation number 1. So 5a. Again, what you did here is you just substitute the value of ft with your 2.1. Again, that is your 2.1. 3a plus 29.4. Again, this is substitution method. So now you just have to, if you can see, you're going to expect that from here, after substituting, you're going to expect after substitution, only one unknown left, okay? Unknown in equation. So you're going to expect that there's only one unknown in the particular equation, because otherwise, well, if you still have more than one there, that means that you need to find another way. But if you can see here, this is already just a single unknown, which is a, which is what I also want to solve. So this is 49 minus, if you can see, this is minus here, minus. So that's minus 3a minus your 29.4, okay, is equal to 5a. So it's equal to 5a. So now this is just a matter of solving for the unknown a. So how would you do that? Again, we just group all the terms with the unknown. So that means that I'm gonna transpose this one. So this is 3 plus 3a plus 3a. And I'm gonna get the sum of this. I can combine these two because they are both whole, just numbers. So therefore, I can combine them, okay? Both are constants. They are similar terms. Well, if you remember, there are similar terms. Only similar terms are or you can combine similar terms, okay? If they're not similar, well, just leave it as is. So 3a and 5a, they are similar terms, so therefore you can add them. So 49 minus 29.4, that should give you same thing as before, 19.6. Okay, 19.6 is equal to 8a. So if you can see, you just arrive at the same expression there. So A is equal to 2.45. So A is equal to 2.5 meters per second squared. The direction is counterclockwise. Okay, you can use either of the two. And actually, if you know how to use your calculator, some calculators have a way of solving systems of linear equation. You just have to set up your equation 1 and equation 2. You just have to write all the coefficient. Like for ft, it's -1 and 1. For equation number 1, it's -1. And then for a, it's 5. And then the constant is 49. So some calculators actually able to do that, like just solving for most probably in your calculator, these are represented by x and y, so you can solve right away for the x value and the y value. You just have to set up your equation, okay? So depending on the format of your calculator. Any question with this one? This is kind of long, but later on I will no longer explain it this way. So I'll just gonna maybe just use one method. Again, this is just a review also of your algebra, like because you'll be, for most cases here, you'll be setting up systems of equation, linear equation. So you can use elimination method or substitution method. So any question with this one here?
Yeah, I have a
Yes.
question.
Yes.
So how do you know that acceleration is going to be positive if it's going down again?
Actually, I'm just trying to compare my M1 and M2 here. So M1 is for sure is much heavier, but actually you don't. It doesn't matter. Like if you have decided that my positive is in the other direction, like in the clockwise direction. So let's say, for example, for some reason, well, randomly, I just choose that it's going this way. So that means that my M1 would be going up and M2 is going down. So when I try to do my free body diagram, the direction of my acceleration, positive is there, and the other one is negative. When I try to solve this one here, incorporate those directions, actually the acceleration that I'll be getting here is a negative value. So a negative value means that, well, the assigned direction in my solution is actually wrong. That means that not necessarily I would say wrong, but I just assumed it wrong. So it just, well, if you get a negative value, for example, like if I try to reverse everything, like for my M1, upward is positive, and then for my M2, downward is positive, right? So if I gonna reverse everything up, the final answer that I'll be getting here is actually this would be negative 19.6 and this is negative 2.45. So that means the negative sign here indicates that, oh, it's not in the clockwise direction, but it's actually counterclockwise. Okay? So it will just come out naturally in your solution. As long as you are consistent, once you decided, okay, if you have decided that this is moving in the counterclockwise direction, that means that M1 should be moving down. So that means that moving down in M1 constitute a positive value. And then for M2, since this is moving in the counterclockwise direction, M2 should be moving up, right? So if it's moving up, that means that the upward direction is my positive direction. But then again, if somehow you misuse the direction, don't worry because in the final answer for the acceleration that you will get here is a negative value. A negative value constitute that, oh, uh, well, I assign or I assume the reverse direction. So that means that if I have used the other way here, clockwise direction, so if I assume initially that this will be moving in the clockwise, so I just try to reverse that. What is the opposite of clockwise? Well, it would be counterclockwise. Okay, Belia,
Yeah.
that somehow answers your question, or
Yeah, I was able to follow, but I think
mm,
it'll be more clear when I see like another example.
okay, yeah. So yeah, although since I'll just be dealing with two masses here, and if you can see, well, there's another way of solving this one, but I just found this like because you are actually when you say net force, you're looking at a single object, okay? But there's also other way. Maybe perhaps your book or the book or the textbook shown it differently, but actually the reasoning behind that is just coming from this individually. You try to get the net force of each object first, and I just find this one much more again helpful and again helpful in reinforcing of what you have learned about Newton's law. Okay.
Okay.
Yeah. And yes. So again, I will not do example number 3, but example number two. But if you want to challenge yourself, you can actually do it at home. Although I'll be giving you a template with the solutions of all the examples. It's just that even in your assessment or in the exam later on or in the test, I'll just be giving you two masses in your pulley problem. Okay, so let's take example number two here. Yeah, in some cases it would be given like this, but essentially, I would employ the same procedure. So a simple pulley system is built on a frictionless. So take note of this one: frictionless surface. But mind you, maybe in your physics 12, Mr. Su will give you something with friction, as shown below. Determine the acceleration of the system if A is, so the mass of the first object is 2.5, and then the mass of the second object is 3.5. So if you can see in this, I think it would be obvious that the acceleration would be, well, for A, it would be to the right. And then for B, the acceleration would be downward, okay? Downward. Or generally, the rotation of your pulley would be clockwise, okay? So that means this system will be rotating in the clockwise direction. So I just gonna set that one again. The acceleration would be in the clockwise direction, okay? And I think it's not in this particular case. It's not that hard to identify that the acceleration would be in this direction, the clockwise direction. Especially that you're given that the surface is frictionless. So again, just like before, you try to draw the free body diagram of each separately. So free body diagram of A and B. So again, free body diagram of each. So I'm gonna draw them separately. So for A, so if this is my object A, so what are the forces? Well, if you can see, it's lying on a horizontal surface. So therefore, there should be FG, FGA, okay? And you have normal force in this case. However, in this particular case, the acceleration doesn't happen in the vertical component. There's no vertical acceleration here. The acceleration only happens along the horizontal. So that means that the normal force is equivalent to the weight of the object. So that means that I don't have any motion along the vertical. However, if you can see this particular object A will move to the right because I have FD, or the tension force, the string, the force of the string here. And again, since I know that this will moving to the right, the acceleration, I'm gonna set that one to the right as my positive. The acceleration is to the right, so anything to the right would be a positive direction. So now I'm gonna go to my object B. So what are the forces acting on object B? So if you can see here, if an object is lying on a surface, well, the weight doesn't contribute to the motion, especially since you have zero friction. But this is more applicable, the weight of the object. Remember, if you have an object lying horizontally on a surface, the normal force is equivalent to the weight of the object. And at the same time, remember that friction between two surfaces that are in contact is dependent on the normal force. So actually in this case, since friction is zero, that means that the normal force or the weight of the object doesn't affect the motion because you don't have any friction here. But in a particular case that you have friction, actually weight computation is relevant, but not in this particular case. So now I'm looking at my object B. Object B is hanging, so you don't have any normal force here. However, I have tension force, Ft, as well as my Fg. This is FGB. Again, I'll just gonna call that one subscript B because again, I have two objects here, object A and object B. So for distinction between the two, I gonna do that one. So again, the weight of object B, because if you can see here, uh, I know that the this will be moving down. So I'm gonna use moving down as my positive direction in this case. This would be mass of B times G. So mass of B is 3.5 multiplied by 9.8. So FGB is equal to around 34.3. Again, I will not be rounding off here because this is not my final answer, but I'm gonna need this value in solving for the net force because if you can see, in my object B, the weight of the object affects the acceleration. In my object A, the weight of my first object doesn't matter, okay? Because if you can see, it's just balanced by the normal force. So now, I'm gonna go to the net forces. So net force on A. So what are the forces along A? So the net force on A, if you can see, is only affected by Ft. And how do you know that one? Well, if you can see, that's Ft. Okay. And again, the net force on an object will always be equivalent to the mass of A times its acceleration. And without, again, the acceleration of the two here should be the same. So therefore, I just use A because both will be accelerating at the same rate. So that would be equivalent to MA times A. So essentially, using the values, the known values that I have, MA is just equivalent to 2.5. So this is 2.5 A. I have two unknowns here, but I have one equation. So this is just one equation that I got. However, I have the other object, which is object B. So I'm gonna check on the forces acting. So I take the sum of all the forces acting on my B. And again, the net force acting on B is just the mass of B times its acceleration. So going to my object B, I have two forces acting on my B that will affect its acceleration, Ft and Fgb. So again, I set my downward as my positive value, so therefore, that should be Fgb plus the magnitude of my negative of the magnitude of Ft. Okay, so that gives me MBA. And now I'm just gonna substitute everything that I know. I already solved my FGB. So the magnitude of that is 34.3. and it's a positive because again the acceleration is downward, so I set that one as the positive direction. And then this is minus ft is equal to my mb is given in the problem, that's 3.5, so I'm just gonna substitute that with 3.5 and then a. Okay, so my mass is 3.5a. So this is my equation 2. But this is simpler than before because if you can see, ft, you're given the expression for ft. So all you need to do to solve for a, so I'm just going to take note here, to solve for the acceleration a, just substitute equation number 1 to equation number 2. Okay, so you just substitute this to here. Okay, so just substitute equation 1 to equation 2. So if I'm gonna write my equation 2, that's 34.3, and then minus ft, and then that would give me 3.5a. So again, the value of my equation number 1, ft is given as 2.5a. So that means that I can replace this one with 2.5a. So I have 34.3 minus substituting the expression, that is just 2.5a, and then equal to 3.5a. So again, what I did here is just substituting my equation number 1 to my equation number 2. So that would be that. So now, upon substituting, well, I think it's much better to do substitution here than just uh, doing the elimination method, because right away you have the expression for your ft. So now I'll just have to solve for my a. So I'm gonna isolate my a. So that means that this is plus 2.5a plus 2.5a. So this gives me 34.3 is equal to, that's 6a. Okay, so now I'm gonna divide both sides by 6 to solve for a. Divide by 6. That gives me a is equal to around 5.7. So now I'm just gonna write it down there. A is equal to, oh, maybe a is equal to 5.7 meters per second squared. And I've chosen the correct direction, so therefore this is clockwise. Okay. So any questions or clarification?
Yeah, I have a question again.
Yes. Okay.
Um,
Well, yep.
for when you're doing like the free body diagram of
Yes.
A, why don't
Yes.
you define FG for A?
What? Anyway, it doesn't affect my motion. Remember that for my object A, the acceleration is just along the horizontal, right? Because in this particular case here, since Fn, so this one here, since Fnet along vertical is 0, correct? It's 0, correct?
Yeah.
So A is also 0 along the vertical. AY is also 0. So you don't have any motion along the Y. The motion is only along the horizontal. So object A will just move to the right or to the left, not the horizontal movement. So again, I didn't bother solving for FGA. However, a more complicated question here is that if you have friction between object A and the surface, because you have FT here, even though you don't have any vertical movement, but remember, friction is dependent on the normal force. And in this particular case, as long as it is lying horizontally, the object is lying horizontally, the normal force is just equivalent to the weight of the object. Okay?
Okay.
So, yeah. That answers your question, Belia?
Yeah, it does. Thanks.
Yeah. So, it's not all the time. Not all the time that you need to solve for the weight. But again, if friction is being considered in this particular case, I need to actually solve uh, for the weight because uh, your friction is dependent on that. Okay. So any other questions?